Welcome to the University of Essex and to the Department of Psychology, and in particular, welcome to this module, Statistics for Psychologists. This is an important part of your psychology degree programme. It's one of 3 psychology modules that you take this year, and it makes up 1/4 of your degree studies for year 1 of the degree programme. Now you might be wondering why your first lecture is online. That's a good question, and I guess I've got a couple of answers to that. First of all, an important function of this module is that we cover a lot of skills that you need to do well on other modules in psychology. And so in order to make sure that you've covered everything that you need to do a good job with your first research methods assignment, we're putting this material online so that we can get through things quickly enough so that you've got everything in place for that first assignment. Additionally, we think it's good for you to have the opportunity to experience a university lecture ahead of the first week of teaching, when you'll have several lectures on several modules. So you can use this as an opportunity to practice getting the best from a lecture. So for instance, you should be taking notes as I go through the material today. And we always want to encourage you to be active in your learning. So for instance, you won't just be listening to me, you'll be doing some activities. And so for instance, you should always have your calculator with you when you come to your statistics lectures. Also, to encourage an active approach to your learning, we follow what I call a workbook approach. So I'll always give you a handout that shows most of what appears on the screen, and you can add notes to that and add things to the diagrams that appear there to help your understanding of the lecture. And then there'll also be spaces where we've put the activities for the lecture, and again you can put your answers to that on the lecture handout. And the purpose of this is to ensure that you engage as actively as possible with the lecture, and that will help your understanding. It's also a way of stopping me racing through things too quickly, so it ensures that I go at what's hopefully a nice pace for everyone. And throughout this module, we'll be taking a step-by-step approach to learning. So a lot of the things that you learn in the early part of the module, perhaps simpler skills and concepts, they will build up together as we learn the more complex skills and concepts. And also, as part of that process, sometimes we'll make use of some of the mathematics that you learnt at school. And when we do that, I'll often remind you of something that you've been taught before. So when I do that, please don't be offended and think that I think that you don't know that. All I'm doing is just signposting for you what the important ideas or skills are and trying to show you how things fit together. So now we're ready to move into the content of the first lecture. Make sure that you've got the lecture handout printed out. Make sure that you've got your calculator to hand. If you haven't got the printout or the handout, you can print that out now and stop the video. Otherwise, we're now ready to enter the exciting world of statistics for psychologists. So you can see from your handout and from this video in front of you that I've titled this first lecture An Introduction to Statistics for Psychologists. So it's an introduction to the module, but more importantly, it's an introduction to an important set of skills and ideas that psychologists make use of. So we're going to introduce you to an exciting and useful set of ideas, skills and concepts that are going to help you get a better understanding of human behaviour. And so in this lecture, I'm going to address 3 broad questions. First, put simply, why are we doing this? Why do I have a module on statistics if I'm doing a psychology degree? Second, what will we be doing? In other words, what kinds of questions will I be able to answer with the skills and techniques that I learn in this module? And how should I do this? I'll be giving you some advice and tips and ideas on how you can best approach this module, how you can master the material and get a really satisfying grasp on the ideas and the techniques that we want to introduce you to. And I want to start with that first question of why, as psychologists, we use statistical techniques. And I want to start with an example. So I want you to think about this example. Imagine that your friend tells you that they've tried something called a subliminal self-help audio track. So this is an audio track that's designed to improve your memory. And what happens is you listen to some relaxing music that you can hear, but there's also a message which is not clearly audible. So there are words there, but you can't make out what those words are saying. That's a subliminal message. And your friend says that the audio track has worked for him or her. In other words, it's improved their memory, according to your friend. And they recommend that you try it for yourself. And so my question here is, what objections might you have to their evidence? In other words, are there perhaps things that might make their claim invalid? Have a think about that. Pause the video and write down a few things that come to mind. And then when you're ready, restart. So hopefully you've thought of at least one or two objections to your friend's suggestion. One or two reasons why they might not have come to a sound conclusion about this self-help audio track. And I imagine that amongst the class we've got a variety of different suggestions or objections to the evidence. These might come in different categories, and so perhaps the first category we might think about is where we might ask, how do we know that the friend's memory has actually improved? And in order to know whether the memory has improved, we need some kind of measure of how good memory is. We need to take some measurements. Perhaps we might do that before and after the technique to see if there's been some kind of improvement. And what we're going to have is some kind of number that represents how good the person's memory is, and in particular, how good it is after using this audio track. Now we might concede that the audio track or that the memory has improved, but do we know that it's the audio track which is responsible for that? So possibly we might say this: maybe the memory would improve anyway. And so what we're seeing is just a natural development and a natural improvement. So what we will need to do is compare your friend against somebody who hasn't used the audio track. A similar objection that we might have is we may concede that the audio track has improved memory, but we might suggest that there are other things that would work at least as well, perhaps a lot better, maybe even quicker and cheaper methods that might work. So maybe something else would work better than this self-help audio track. And again, we want to undertake some comparisons. Here it would be a comparison between your friend who's listened to the audio track and somebody else who has used this other technique. So we may concede that your friend's memory has improved. We may even be satisfied that the self-help audio track is responsible for that. But another objection we might have is this: how do we know that it works for other people? Maybe it works for the friend, but maybe actually there aren't that many people for whom this would work. So there's a question we might ask. How general is this result? And so what we would need to do now is not just make a comparison between one person using this track and one person using some other technique. We want to look at groups of people. And we want to measure their memory. And what that means is we're going to get a collection of scores. So we're going to have to find some way of aggregating or summarizing the performance of these different groups. And we're going to have some way of comparing one group against the other. So if you think about those kind of questions that we've posed, those kind of objections that we've come up with, and the solutions that come with those questions, then hopefully this gives you a little bit of insight into why we need statistical techniques as psychologists. Here's a good psychological question. How does the memory work? How effective is it? What might improve it? And in order to address that, we need to do some measurement and we need to do some comparison. So just in this simple example, we see a little chain of events where statistical techniques are going to be really important. So as psychologists, we want to study behaviour. And as a consequence of that, we need to observe what people do, and we need to carefully measure the behaviours that they engage in so that we can get a precise image of what they're doing. As soon as we've got those numbers, we're going to have to analyse that data. And from that analysis, we want to make an evaluation. And we want to be able to draw conclusions. And that's why we need statistical techniques. This is going to be an important part of finding out more about what people do, why they do it, how they can change their behaviour, how we can improve their performance, and so on. And there are at least a couple of important goals that we're going to address in this module. One of those is that we want you to be able to understand the psychological research that others have done. We want you to be able to read reports of research for yourself, and understanding statistical techniques will give you a better understanding of that research and therefore a better understanding of what we know about human behaviour. And secondly, we want you to be able to carry out your own investigations. So we want you to be able to do your own research in psychology, and following this kind of procedure, it's going to be important that you know how to analyse data correctly yourself and how to draw conclusions in a principled way. So what I want to do now is turn to that second question that we're going to look at this lecture. What is it that we'll be doing in this module? And I'm going to jump straight in with 3 examples that I want to use to illustrate how we might make sense of the kind of information or data that psychologists collect, and how we might begin that process of answering interesting psychological questions by using statistics. So this is my first example. It's a slightly curious kind of study. So what happened was this. These researchers set up a table at some kind of outdoor event, so some kind of fair or festival, and they set up a taste test table. People were able to come and try 2 types of ketchup, and they had to say which one they preferred. One of them was just a normal ketchup, nothing unusual. The other one was the same ketchup, but with a little bit of vanilla flavouring added. And then, after people had said which one they preferred, they answered a series of questions. Now, one of those questions may sound a little bit odd, but it relates to a hypothesis, an idea about what would happen that the psychologists had. People were asked, as a child, as a baby, were you bottle fed or were you breastfed? And their reason for asking this question was because for the age group of participants that they recruited, and in this particular country, the formula milk that you would have had if you were bottle fed had a small amount of vanilla flavouring included in the ingredients. So what we have is one group of people who decades earlier had had some initial exposure to vanilla flavouring that some other group didn't have. And they want to compare those two groups as a way of getting a little bit of insight into whether those very early experiences of flavour or taste have an impact many years later. And I've got this diagram here and here that shows what people's preferences were. So a shaded diamond represents somebody who preferred vanilla ketchup, and an unshaded diamond is someone preferring the pure regular ketchup. And in this format, it's not really very easy to make a comparison between the two groups. So what we need to do is have some kind of way of organising the data. And that's what I've done below to start with. I've gone through and I've counted up that in the bottle-fed group, 20 people out of 30 preferred the ketchup with added vanilla, and in the breastfed group, 30 out of 103 people preferred ketchup with added vanilla. Now what I want to do is go to the next stage, which is to not just collect together the information, but to summarise it in a way that allows me to compare the two groups. And a good way of doing that is by calculating the percentage of people in each group who prefer the vanilla flavoured ketchup. It's important that we look at a percentage because we've got quite a lot more people in one group than in another. So we can't just say, well, in the breastfed group, there were more people who liked the vanilla flavoured ketchup, because actually there were a lot more people in that group anyway. So let's work out a percentage for each group. In the bottle-fed group, 20 out of 30, if we write that down as a fraction and then remind ourselves that this requires us to do some division, that will come to 0.667 as a proportion. Now that's not the percentage. I need to multiply that by 100, and then that will give me, if I round it off, 67%. Let's do the same for the breastfed group. So we can write those numbers as a fraction. So that's 30 out of 103 people. And then if we do that division, then that works out to 0.291. That's the proportion, it's not the percentage. So multiply by 100, and that gives us, if we round it off, 29%. So taking these numbers at face value, what it would look like is that early experience with vanilla flavouring may well have had some kind of impact on people's later taste preferences, and much later. This is decades later. And so doing some calculation, finding some way of summarising the information for each group allows us to make a comparison and to draw a conclusion. So now to our second example. So these researchers, led by Greenwald, they were interested in these subliminal self-help audio tapes that I told you about earlier in the lecture. And they wanted to test out whether they worked in the way that they were supposed to. And they came up with a clever way of assessing these tapes. They had a tape that was supposed to help you with your self-esteem. In other words, in simple terms, help you feel better about how you feel about yourself and how you feel about your qualities as an individual. And what they did was they gave one group of people that self-help tape that was designed to improve their self-esteem, and they gave another group of people a range of subliminal self-help audio tapes, but ones that were designed to help other things, so memory or confidence or whatever. So a variety of different things. So this was basically the control group against which we compare the people who are given a self-esteem tape. And as in our opening example, they had to have some kind of way of measuring people's self-esteem. And there are fairly well-established ways of doing this. For instance, there are questionnaire measures that have several questions and give you a score. And what you see here are the change scores. In other words, how much somebody's self-esteem has improved from before they started using the tape until after they used the tape. And so if their self-esteem improved, they'll have a positive score, and if it improved by a lot, they'll have a high positive number. If their self-esteem didn't change, they'll have a score of 0, and if their self-esteem, according to this measure, got worse, they'll have a negative score. And so what we've got here are the individual change scores for each of the participants in the study. And again, this is in a format that doesn't make it easy to compare one group against the other. So what we need to do is find some way of summarising the data which allows us to make a comparison between the two groups. And a good way of doing that is to say, well, what's the average for each group? And then we want to see how similar or how different those two averages are. So you can think of it as an average as a number which tells us, well, what's typical for that group? So let's do that for the self-esteem scores. So to get an average, we can total up all of those scores. You might like to check this later with a calculator, but the sum of those scores in that upper row of numbers comes to 320. Now there are 20 individuals there, so the average we can find by doing 320 and dividing that by 20, and that comes to 16. So we can put the average there, 16. Now let's do it for the other group. If we total up all those scores in that second row, again, check this later when you've got a moment to do so, it comes to 340. So for this group, the average is 340 divided by the number of people, or the number of scores that I've added up. Again, it's 20. So when I do 340 divided by 20, I get 17. Now, when we judge the 16 against the 17, we should have a look at the kind of individual change scores. And we can see that they're fairly variable. So that difference of only 1 is probably really a very small difference. And so in this situation, we'd probably say, actually, there's not much difference between the tape that is designed to help your self-esteem and the tape that is designed to do something else. And now to our third example. So these researchers were interested in testosterone, which is a hormone that we have in our bodies and which is usually there in higher concentration in men than in women. And they were also interested in criminal violence. So for this study, they looked at prison inmates. Now these were prison inmates who were serving time for non-violent crimes, but they also wanted to measure how violent they were in this prison situation. So they measured two things. They measured their testosterone, and they did that by taking samples of saliva, and you can measure the concentration of testosterone in the saliva. And then for each prison inmate, each prisoner, they also went through the prison records and they tried to assess something about the level of violence that that person showed. And the way that they did that was to look at the records for the punishments that they'd received for rule breaking, which would usually be for some kind of violent behaviour. And they looked to see, on the average, how many days punishment did each person receive. And the idea is here, the more violent you've been, the more punishment you will have received, because you'll have been doing more violent, more serious acts that would have got you into trouble. And so what I've shown here in a table is a list of the information for 15 prisoners. So for each prisoner, it shows their testosterone concentration, and it also shows the number of days punishment per infraction, in other words, per time that they break the rules. And although this is a nice organised list, it makes it very difficult to see if there's any kind of link between the testosterone and the number of days punishment that people get per infraction. In other words, we've got two sets of numbers in those second and third columns that we're interested in. We want to see if there's some kind of link or some kind of pattern that relates one to the other, and yet from this it's very difficult to see. There's a much better way for us to see the pattern. So here's what we can do. We can produce what's called a scatter plot. In other words, we can plot each combination of the numbers that we're interested in on a diagram that will allow us to see if there's a link between the two pieces of information that we're interested in, the saliva testosterone concentration and the number of days punishment per infraction. I'll show you how to get started with this. So I've got this grid set up in Excel, but I'm going to get you to do it by hand on your own handout for this example. So for the first inmate, their saliva testosterone concentration was 4. It's measured in nanograms per deciliter, but the key thing is the number we're looking for is 4. So that's along the horizontal axis. We count 4 across, and then their number of days in fraction is 0. So for them, their point is going to go there. 4 across and 0 up. Then the second inmate, they have a saliva testosterone concentration of 10. So we're going to go across to 10 on the horizontal axis and then count up to 6. And that's going to be there. So I want you to pause the video and then complete the scatter plot for yourselves. So welcome back. Now that you've completed your scatter plot, it should look something like this. And what I want you to do now is think about how you can describe the pattern that you see. So you should be able to see some kind of pattern that shows that there seems to be some kind of link between the two sets of numbers that we've plotted on this scatter plot. So some kind of pattern that relates the saliva testosterone concentration to the number of days punishment per infraction. And try and do that description using fairly simple words. don't use technical jargon that you might know. Do it in as simple a way as you can, perhaps so that a 13-year-old or a 14-year-old child could understand what you've written. So pause the video now and write down your description of the pattern that you're looking at. So welcome back. Now, there are a number of ways that we can describe what we're looking at here. One thing you might have written is something like this, that higher levels of saliva testosterone tend to go together with higher number of days punishment per infraction. Or you could equally well have said that lower levels of saliva testosterone tend to go together with a lower number of days punishment per infraction. Another way you could say it is this: as the saliva testosterone concentration increases, so also the number of days punishment per infraction tends to increase. Another way that is perhaps not so common, but we can also see here, is we could say that higher than average levels of testosterone concentration tend to go together with higher than average levels for the number of days punishment per infraction. And notice that in all of those ways that I've described this pattern, I've qualified things. I've been slightly cautious. I've said things like tends to, because we can find certain pairs of data points on this graph that don't fit in with the general pattern. But most of the points fit in with the pattern that I've just described to you in different ways. Now we'll see towards the end of this term that what we're looking at here is what's known as a linear relationship. So this idea that as one thing tends to increase, the other tends to increase, is often described as a linear relationship or a positive correlation between two variables. So let's move on from this example. So let's recap a few key things about these three examples. So in the first example, we had two groups of people in our study. And we compared those two groups on some measure of behaviour. It wasn't a very detailed measure of behaviour, it was simply whether they preferred one ketchup or the other. So it's a two-category measure of behaviour, not very detailed. Our second study also examined two groups, but here we had a more detailed or more precise measure of people's behaviour. It was the self-esteem change score, and so you weren't just in one category or the other, you could be at several points along the scale. So you might be very similar to somebody else who had a different position on the scale, or very different to somebody else who had a different position on the scale. Notice that in the first study, our two groups were naturally occurring. We didn't put people in those groups, we just took people as they are and we asked them information which told us which group they were in. In the second study, they were assigned to the two different groups, and that distinction between assignment to groups and naturally occurring groups, that will sometimes make a difference to what we can conclude from our studies. But in both of these, we were comparing two groups. Our third study, we didn't have two groups, we just had one group of participants, but we had two measures. So there were two measures of behaviour. That we obtained for all of our participants in our studies. And again, these were more detailed measures. So both the saliva testosterone and the number of days punishment per infraction, you could have one of several different values on that measure. Now let's think about these examples in terms of 6 important definitions that we're going to use throughout this year. I've already used some of these. First of all, we need to understand what we mean by a variable. A variable is simply something that can vary. I've defined it here as a property of an object that can take on different values. And in psychology, the objects that we're interested in are usually people. So for instance, the self-esteem change score or the ketchup preference, those are variables. They're things which are different for different people. Likewise, the number of days punishment per infraction, the saliva testosterone level are things that vary from one person to the next, and so they're variables. When we focus on one individual in our study and see what value the variable takes for them, then we're focusing on a score. So a score might be something like self-esteem change value of +2 or -1. A ketchup preference of prefers vanilla ketchup. These are examples of scores. For the individual, they just have one value. Next, we've got a pair of things that we need to understand in connection to each other: population and sample. So the population of scores is the complete set of scores that we might be interested in. So for that study with prison inmates, although we had 15 prison inmates, we're probably interested in not just those 15 individuals. We're interested in the scores for perhaps all of the prisoners in that prison, or maybe even all of the prisoners in the entire prison service from a particular category of prisoner. When we look at the scores for a subset of that population of scores, we're looking at a sample. So for instance, in the first study of ketchup preference, we didn't look at everybody in a particular age group in the entire country. We might be interested in principle in them, but the practicalities of our study mean that we just look at some people. And the scores for that subset of people, that's the sample of scores. So notice that strictly speaking here, the population and the sample refer to scores, not to people. They're the scores from the people. And that differs slightly from the way that we use these words in everyday language. The final set of, or the final pair of terms down here, they are also to be treated as a pair. They kind of go together. So parameter and statistic. So when we summarize a set of scores, if we're summarizing a population, that's the parameter. If we're summarizing the sample, that's a statistic. So an example of a statistic would be the percentage of people preferring vanilla ketchup. We might be interested in the percentage preferring vanilla ketchup in our entire population of scores. And if we were able to get that, well, that would be our parameter value. Now, typically that's not practical. So we use the statistic as a guide to the parameter. Another example of a statistic that we had is the average self-esteem change score in each of those groups. It summarizes the scores in a sample. So these 6 definitions, they'll be important throughout the year. So what I want to do for the next few minutes is concentrate in a little bit of detail on that second question for this lecture. What is it that we'll be doing in this module? Well, we'll be focusing on 2 different kinds of data: categorical data and measurement data. Measurement data are those more detailed measures of variables that I mentioned a few minutes ago. So for instance, a self-esteem score, you can be at one of several points along a scale from low to high. Or a self-esteem change score. Your change could be a small change or a large change, it could be a negative change or a positive change. There are lots of different possibilities. For those kinds of measurement, we call that measurement data. So other examples would be the number of days punishment per infraction, or the amount of testosterone in your saliva, or the concentration of testosterone in your saliva. Categorical data, also known as frequency data or count data, those are the number of things in a class or category. So for instance, the number of people preferring vanilla ketchup in a particular group. That's an example of count data or categorical data. The number of people who were breastfed in that first study. That again would be some categorical data that we could get from the study. So the number represents how many people are in a category. What else will we be looking at? Well, we'll be looking at two types of pattern or phenomena, differences and relationships. So examples 1 and 2, we looked at differences. In other words, we took some measure of behaviour, we divided our people, our participants, into two groups, and we made some comparison between those two groups. And the kinds of questions that we're interested in answering are things like this. Are the groups different? In other words, for some summary statistic, are they the same or different? If they're different, how different are they? And then a more advanced question, I've phrased here in this way. Do I trust that there's a genuine difference? In other words, based on my sample data, should I conclude that there's a difference in the population? And that's a tricky question to address, and we'll get a special set of techniques in order to do that. Relationships are where we look at how scores for one variable relate or go together with or line up against those for another variable. Our third example, where we examined saliva testosterone and number of days punishment per infraction, that's an example of examining a relationship. In other words, we measure two variables, we do that for several individuals, and we look at whether the values of one variable match up or line up with the values for the other variable in any way. If they do, we ask questions like, how close is the match? And do I trust that there's a genuine relationship? In other words, what I mean there is, based on my sample data, am I able to conclude that there's a relationship in the population? What else will we be doing? Well, we'll be doing what I've called here two types of activity. We're going to be describing data and we're going to be making inferences. In other words, drawing conclusions from data. So we're going to learn some techniques for describing data. We call that descriptive statistics. So how we might summarize samples, giving the key points in a simple form. So think about those three examples. We had a lot of numbers, we had a lot of data, or we had a lot of people in different categories, but we found some way of summarizing the information so that we could see what patterns were there, or get an idea of what differences were there between different groups. And we might use graphical techniques to provide a summary, as we did with the scatter plot in the third example, or we might use some kind of number, as we did in the first two examples, to provide a summary of our data. Inferential statistics is something that we won't cover in the first couple of weeks of term, but it's a very important topic that we'll get to a little bit later on in this term. And this allows us to evaluate the evidence for a hypothesis. In other words, for something that's been proposed as an idea that we can test with data from a study, inferential statistics will allow us to draw a conclusion. In particular, in statistical terms, what we're thinking of is this. How can we draw conclusions about a population of scores based on the analysis of a sample of scores? And I'm going to give you a little example to give you a flavour of why we use inferential statistics and a little bit about how we use them. Now, to do that, I'm going to take you outside. So, as an exercise in drawing conclusions from data, let me tell you about a study by two researchers named Rakow and Zhuan. So they were interested in driver behaviour, and so they came somewhere like this to a car park, and what they wanted to look at was how long it took people to leave their car parking space. And so what they did is they timed drivers from the time that they arrived back at their car to the time that they left their car park space. And on the basis of the measurements that they took, they concluded that drivers take longer to leave a car parking space if somebody else is waiting for their space. Drivers take longer if somebody else is waiting for their space. Now, I want you to imagine that their conclusions were based on the following findings. Let's say that on average, drivers took 32 seconds when no one was waiting for their space, and on average, drivers took 39 seconds when there was somebody waiting for their space. So that's a 7-second difference. But also imagine that they'd only timed 4 drivers. Only 4 drivers. Would we feel that it was a good general conclusion on the basis of that study to say that drivers take longer to leave their car park space if someone is waiting for it? Probably not. We probably wouldn't feel that only observing 4 drivers was enough to give us reliable information for drawing a conclusion. Now let's imagine a different state of affairs. Let's suppose that they actually made observations for 200 drivers. This time, let's imagine that for drivers where there was no one waiting for their space, the average time was 35.6 seconds. And let's imagine that for drivers where there was somebody waiting for the space, it was 35.7 seconds. So it's true, drivers on average take longer to leave their car park space when someone is looking to come into that space, but would we feel that we've got a good basis for a general conclusion? Again, probably not, because this time, while we've got a lot of data, there isn't a clear difference between the two groups that we've examined. The reason I've told you about this is because inferential statistics are used to see if we've got enough data and a clear enough pattern in the data for us to be able to draw a general conclusion. In other words, we use what's called inferential statistics to see if we can draw a conclusion from our sample and apply that to the population. So think about our example that we've just talked through, or our 2 examples that we've just talked through. In one case, there was a fairly clear difference between the 2 groups, but we didn't have much data. In another case, we had a lot of data, but there wasn't a clear difference. So in neither of those cases do we have a good basis for a general conclusion about the population. Now, in fact, what Rakow and Zhuan did was they looked at 200 drivers and they found that 7-second difference. So they probably did have both enough data and a clear enough difference between their groups to be able to draw the general conclusion. And having established that there's a difference, they were then able to examine why they get that difference. So for instance, to ask the question, is it because drivers are distracted? Or is it because they're worried about a collision? Or maybe even is it the case that there's some kind of instinctive territorial behaviour whereby when you own something, like a parking space, you want to assert your ownership of that space. And in fact, they conducted a number of different studies, and that was their preferred solution on the basis of their different studies. So that is a little insight into something that we'll be covering later on this term, inferential statistics. So I've shown you a little bit of what it is we're going to be doing in this module. And I've said something about this briefly at the start, but let's look in a bit more detail at why it is we're doing this and what exactly it is we're going to get out of taking this module. So think of statistics as a set of skills that you're going to learn. And it's about understanding and it's about communicating. So really you're going to be learning a language to communicate what we found out from psychological data. And as with any skill or any language that you learn, it's important to be practical in your learning. You're never going to learn a new language or you're never going to learn a new sport just by hearing about it. You actually have to practice and keep doing what you've been shown, and then you will understand things better, but also you'll be able to use those skills more effectively. And in terms of the process, we're going to be using techniques to evaluate evidence. In other words, helping us decide what we think about particular theories or ideas that people are putting forward, and what it is that different psychological studies tell us about those theories and ideas. And we often follow this little three-step pattern. We describe the data. For instance, we might assess the size of differences or how clear the relationship is between two variables. We then undertake some kind of test. In other words, this is where our inferential statistics come in. We're evaluating the strength of evidence for a particular theory. And then we draw our conclusions. On the basis of our statistical analysis and our inferential testing, we decide whether the evidence supports a particular explanation, and maybe whether it favours one explanation more strongly than another. Why else are we doing this? Well, I've got a couple of broad categories of suggestion here. I've said we want to make you a better psychologist. So yes, for statistics, it will help if you're good at maths, but you won't need to be brilliant at mathematics to do well at this discipline. And we want you to do well at this topic because we want you to be able to understand the psychological research that others have done. That will inform your understanding of human behaviour and your understanding of psychological insights into that behaviour, because you'll be able to weigh up different theories for yourself, and you'll be able to understand the limits of those theories. You'll get a better appreciation of when those theories apply and when they don't. And also, we want you to be able to conduct your own psychological studies and write them up and report them in ways that people can understand. And I've put here that learning statistics will actually make you a better citizen. In other words, it's part of a general education that's really useful even if you never work as a psychologist. So politicians, newspapers, scientific press and so on are always putting forward evidence for particular ideas. And often that evidence has a statistical basis to it. And you'll understand that and you'll be able to critically evaluate it much better if you have a good grasp of statistical techniques and statistical concepts. And in a very practical way, this is an important set of skills that are good for your employability prospects. So these numerical skills, these quantitative skills that you'll get through this module are things that are going to be valuable in a lot of different jobs. And so it will open up a wider range of employment opportunities to you. So now let's focus on our third question for the lecture. How should we approach this module? So I want to tell you about the general approach, what our focus is in this module. So we always want you to be focusing on understanding things. There will be some mathematics, there will be some calculations, but that won't be the main part of what we do. We always want you to have a good understanding of what the numbers mean and what the numbers tell us about behaviour. And in order to achieve that, we're going to teach you a computer package called SPSS, and that will take out the difficulty in calculation. So the computer is going to be much more accurate than we could ever be. It's going to be much quicker as well. And so this package, SPSS, is a commercially available package, and we're going to make sure that you get a good set of skills so that you can undertake statistical analysis at a professional standard. And we will focus a lot on skills, not just on the theory or background knowledge of concepts. We want to be hands-on with what we teach you. So how will we achieve this? So we've got a varied programme for this module. Each week you get a 2-hour lecture. We typically have a 10-minute break in the middle of that 2 hours. And this is where we introduce the concepts and the ideas, get you to do some practical activities, but this is about giving you a framework for understanding things. Later in the week, you've got a practical class. Unlike the lecture, that's not with the entire year group. You're split into 3 separate groups for those classes. This is where, in particular, we'll focus on giving you the computing skills to be able to do data analysis. And this is an opportunity, more so than in the lecture, to work at your pace, the speed that you like to go at, to ask a lot more questions, to work collaboratively with somebody else, and get a good understanding of the skills that you need for this module. Twice a term, you'll have an additional workshop. That's also in your practical class groups, so not with everyone, but with a third of the year group. And here we'll focus on things that are perhaps difficult concepts where it helps to do a bit of practical work to get your head around a particular idea. Each week we'll give you reading, usually from the module textbook, and that needs to be done before the following week's lecture. So things will build week by week, and if you get behind, you'll find it difficult. So really work hard to keep up with the set reading. And each week you also have weekly exercises. So these are questions, usually from the module textbook, and you'll also have the answers so that you can mark your own work. So you can check your progress, and if you're not able to get the right answer, or you're not satisfied with the way that you've got to the answer, come and speak to somebody, and you can get some help with that work. That's not all. There are other elements which aren't necessarily there every week. So every few weeks we'll give you a self-assessment where, again, you can check your progress not just for the most recent lecture, but for a few lectures. We'll give you what we call tutor-marked homeworks a few times a term. You hand that work in, and this will get marked and you'll get written feedback on your work, usually a mark and other stuff to indicate how well you're doing. And then for each of the coursework tests and the end of year exam, we give you specimen papers and practice papers so that you can see the exact format of the questions and have more questions to practice on and to hone your skills. And we really want you to have as many opportunities as possible for working with others, so for working collaboratively, both with your classmates and with staff. So the lecturers have weekly office hours. So these are not the only times you can book to see them, but at this time you can just turn up without a pre-arranged appointment. They'll be there and you can just drop in with your question that you've got. We're happy for you to see us at other times in the week, but it's best to email in advance to make an appointment. There are also tutoring sessions where a member of the teaching team will be on hand, so that if you've got questions from the practical classes to finish off, or you've had difficulty with something in the weekly exercises, this is a good opportunity to go and get some help. And any time during the year, if you've got questions about the course and questions about the material in this module, you can ask, perhaps by emailing the lecturer, or better still, by posting your question online. So the course materials are delivered through a system called Moodle, and that will have an online forum where you can post a question, and then everyone gets to see the answer, which will benefit everyone in the class. So we do encourage you to work with others and to take up as many of these opportunities as you can for working together. The computing facilities that you need are widely available across campus. So this computer package, SPSS, that we teach you, it's on many machines around campus, and including on all of the dozens of machines that you have access to in the psychology department. And any time between 9 and 5, in and out of term time, you can come and use those facilities. So if you have questions about that, do email me, but more importantly, during the year, once you've been given your work, do keep in contact, do make contact if you're not sure about things. What I'm going to do now is to walk you through what work you need to do ahead of the next lecture. So your next lecture will be in week 2, that's the week that follows Welcome Week. So this is your reading for this introductory lecture. It comes from your module textbook, which if you're buying the most recent edition is shown here below, and you can get this from the university bookshop. The first chapter in that book is written by David Howell, and it comes from his book Fundamental Statistics for the Behavioural Sciences. So read that ahead of the next lecture. And when you do that reading, and when you review the notes that you've made in this lecture, make use of this. This is your learning checklist. You'll get one of these each week to show you the key concepts, ideas and skills that you need to have grasped from the lecture. You can also use this to help you see what's coming up in the lecture. So when you get your lecture handout ahead of the lecture, have a look at this, and it will give you an insight into where we're headed with the lecture. It'll give you some key points to look out for. And these are your weekly exercises. So these are the questions you should attempt before the next lecture. You can work with someone else if you like, and you've got answers. So the idea here is that you can mark the work yourself and check that you're on track. If you're not sure about something, or you're not sure about one of the answers you've come up with, by all means get in touch. But do make sure you've done this before the next lecture. So that's the end of your first lecture for this module, Statistics for Psychologists. Do make sure that you've done all the work that you need to ahead of the next lecture, and I very much look forward to meeting you in Welcome Week and at the first lecture. Thank you.